Hello, is this thing on? Is this working? Oh my gosh, I think it is. Hello, everyone, and thanks for coming by to the live stream. Here we are. It's John Park's Workshop, and I'm fixing things on the fly here because that's not the name of today's show. Today's show is Halloween Prop Teardown. Down. There we go. How's that? That should appear on your screens. Yeah, almost automatically. So yeah, I had the audio system go completely silent on me right before the show. I had to restart the machine, and that makes a bunch of stuff unhappy. So I'm glad it seems to be working now. I'll try not to curse it by saying it's actually working. But hey, thanks everyone for stopping by. We've got Gary T and Connor McCarter and ShuttlePod1 and Dave Odessa over in the YouTube chat. Thank you for coming on over. And then we got a whole slew of people in our Discord chat. If you're wondering where that is, you can head to the Adafruit Discord. It is, you can go to adafruit.it/Discord to get an instant link in to join up. And then this is the live broadcast chat channel that we're in here. And one of the things I'm testing mostly new, I tested it last night during the live stream for the unboxing, is I am running some of my applications in their browser versions today, rather than their standalones. Based on a suggestion from Todd Kurt, I was running Discord as the standalone app. I was running Slack as the standalone app. I was running Basecamp as the standalone app, and there's a decent possibility that those were causing trouble all being open. So I've got the browser versions of those running today instead, and we'll cross fingers. So what else have we got going on? Thanks everyone for stopping by the unboxing for AdaBox 20 last night, for those of you who did. That was a lot of fun to do. If you are curious, you can go back and watch it. We have the live stream archive up on our YouTube. And if you are like most people, you probably haven't gotten your AdaBox yet. Those are all in process. Either parts are still heading over here to get assembled and boxed up and shipped. Some of them have been put together and we're waiting to ship them. Some of them have been shipped. Show of hands, has anyone gotten theirs yet? I'm curious. I think some maybe have gotten out. We've probably had some real shipping going on for a week or so now. So again, we thank you for your patience with that. It's the world we're living in right now. And if you are patient, I think it'll pay off because it's a really fun AdaBox. And there's going to be one in the winter. So if you didn't get involved in this one and you're looking to do AdaBox, it's now possible to sign up for AdaBox 21, which will be the winter one. Rich Sad says, it's the worst thing that ever happened to me. Just kidding. Yeah, if that is, as Phil likes to say, if having a delayed AdaBox is really going to cause you a bunch of agita, then you may want to consider pausing your subscription, and someone else will be able to jump in on that. So let's see, what else? I don't have a recap for the product pick of the week show this week because I did not do the product pick of the week show. I was busy with some editing and prepping and stuff for the unboxing. This is what the prior week's one looked like when I did the haptic motor driver, and there's plenty more from where that came from. So I have a cool product pick lined up for next week. I won't tell you what it is, so that'll be some more exercise in patience and anticipation. And I am sorry I didn't dress up for Halloween today. I did a little bit of dress up last night, and then over the past few days as I filmed and edited the unboxing. So I've got some of my stuff that I used out there. There's that great Devil Seer mask back there. You can probably see him wearing some glasses. And this was the very cool, let me get this out, giant head for the To Serve Man alien. It's a great mask right there. So I'm set if I suddenly have to go, let me punch your head out there, buddy. If I suddenly have to go and be an alien somewhere, I'm set. Look at all the foam they put in the top of this. It rests on top of your head. So that it doesn't cave in. So that was fun. what else? I do have one sort of Halloween prop costume themed thing that I'll show during the CircuitPython today. Sorry, the CircuitPython Parsec today, where I go over some cool tips and tricks in CircuitPython. I will mention we've got the jobs board, so anytime you want to go and post for a position, if you're looking to hire someone, or if you are looking to get hired, head on over to jobs.adafruit.com. All you need is a login. It doesn't cost anything. It's free, and you can post a position. It will be reviewed by Phil and Lamore. They'll take a look at it and see if it's a good fit for our audience, and you'll know it's been gone over and should be something that some of our viewers would be interested in. Let's see, what else? So we're going to do a Halloween prop teardown today. That was my sort of, hey, I don't have a real project because we've been consumed by AdaBox stuff where I'm not building anything from scratch, but I can take something that someone else built and hack it apart and have a look at it, and maybe some considerations for hacking it further or modifying it if we want. So that should be a lot of fun. And I think we'll get on with it. So how about time for the CircuitPython Parsec? Let me get prepped and ready. Here we go. All right, here we go. So let me turn this on so that we have a little idea of what we have to look forward to. For the CircuitPython Parsec today, I wanted to talk about using a microcontroller to control two separate strips or rings of neopixels. And as you can see by my code, this is a little demo example from my good friend Todd Kurt, Toddbot as the internet knows him. He shared this with me, and I wanted to share it with you. It's perfect for this type of goggles project. You can see I've got a couple of prop goggles, and I've got a Gemma with a little LiPo battery. It's kind of tucked in there. And this is running two 16 neopixel strips, I believe it is. Yeah, the code there says 12, but these are actually 16. It's on a different pin. So in fact, let's edit that right now, real time. These are on, I believe, D1. Whoops. Oh, I just confused. Hold on. I just used a keyboard shortcut by accident. Is that going to happen again? Is it listening? It is. Oh, that's new. My I can't type 1 and 2. Wirecast is listening to my keyboard shortcuts, even when I'm not on Wirecast. Okay, so I'll be careful with typing. This doesn't. Yeah, watch. This will break it too, maybe. Yep. And okay. So let's go fix some things. Let's get that out of the way. All right. That looks good. We'll start this from scratch. For the CircuitPython Parsec today, I wanted to talk about controlling a pair of neopixel rings from a single microcontroller. So this is a pair of prop goggles that I have, and I have two 16 neopixel rings. It's being controlled by a Gemma, which is an M0 based microcontroller, and I have a little LiPo battery tucked inside of there. This code from our good friend Toddbot allows us to do a very succinct bit of code that gives us this nice spinning neopixel effect on two separate neopixel rings, and you can see they're going in opposite directions. So the key things are we're importing some libraries, board, time, neopixel, and random. And then we're used to setting up a neopixel strip. Here we got one called LEDS L for left. And the command there is neopixel.neopixel on board D1. 16 is the number of neopixels and a base brightness. Then I have a second one. So this one here, LEDS R, is neopixels on, I've said board D2 here. I think it's actually on D0. And I've got 16 neopixels on that one as well. Then we have a variable called I, which is used to step through each neopixel. And we have a value to dim each subsequent neopixel. So this is what allows us to have this nice sort of glowing trail. Then we have an I color to start with. And then in the main loop, we actually have a pair of these sort of multi-bracketed. It's like a for loop inside of a for loop. And what this does is it says for the left LEDs, we go from 0 to a maximum of I, which is our starting variable, minus that dimming by amount. And that is inside of this max loop, so we never go lower than 0. So we start at 255, then we're going to subtract 50 from it, subtract 50 from it, subtract 50 from it for each neopixel until we get to 0. We are also iterating through all of the 16 neopixels in this case, and then we're doing a slight change in the code here. It says J is the length of the neopixel strip minus I minus 1, and that's what allows us to go backwards on that other strip. Iterate through that, change it to whatever the eye color is, which is dimming with each pass through, and then show the neopixels. We then pause for a tenth of a second or a hundredth of a second and continue on. And so this is how you can control 2 separate neopixels from a single microcontroller inside of CircuitPython. And that is your CircuitPython Parsec. And a big thank you goes out to Todd for the code on that, my longtime collaborator and friend. He does the coolest stuff, so thanks, Todd. And thanks for your patience with my Wirecast session. That's a new one on me. I did not, I've never had it. I wonder if there was an update to the version that I was unaware of, because normally it has to have focus for keyboard shortcuts to do anything, and now it's acting otherwise. So that's pretty bizarre. Yeah, these are actually some goggles I had made a couple of years ago. My daughter used them in a prop, a costume situation. She wore them on top of a steampunk hat. So these are great to put on top of something. You could even put them on top of our LED glasses if you want. You can see through, I can see through that one right there. That's got a little lens there. This one has the battery and the microcontroller in the way, so we don't see through that eye. And I don't really want a lipo right on my eyeball, so better to wear that kind of as a headband, I think. And also, speaking of Halloween blasts from the past, the model that was modeling our delightful goggles is one of my milk jug skulls. So I started with a prop skull, and then I used a milk jug and a heat gun and a wet sponge to melt and conform to that shape, which is a nice way to create some basically free, other than your time, skulls. So you can create a lot of them, have a little skull melting party, and build up an array of skulls for almost nothing. Let's see. Looking in the chat here, we've got some people. Hey, John O says pending is the status of their AdaBox 20. Got some Beastie Boy fans out there too. Excellent. Let's see. Let me pop the Discord on there. What else is going on? I see pictures. What's ooh, very cute. Lots of neopixels, guitars, baby Yodas. What's he called now? Grogu? Is that his name? I have not seen the second season of The Mandalorian. I really need to catch up on that. But I think his name is Baby Grogu, something like that. You can tell me in the chat. Who's this Yoda guy? Yeah, speaking of FFT visualizations, if you see Slappy back there, I think he's hidden in this view, but if I jump over to the main cam view and hide my Discord, you'll see Slappy's back there running, hey, ho, hey. You can see he's got that nice little sound visualizer running on his glasses there. All right, well, hey, I think it's time, in fact, to jump on over to the workbench, and let's dive into this teardown of a Halloween prop. So let's see if my camera switcher is still working. I'll jump to that view right there. Yeah, that should do it. There I am. Okay, so you can see well enough. I'll get this off to the side. So this is an animated eyeball doorbell. I just bought it. I walked down to a Halloween store. We actually have those, and it's a year-round Halloween store. But these, you can get them at drug stores, hardware stores. They carry them at the big box hardware stores. I know you can get them online. They usually cost around $15 or so, sometimes a little more, sometimes a little less. And it is a battery-powered prop doorbell. Check it out. It is animated, and it is visual, and it is loud. So here we go. I'm going to push this to ring. Very cool. And you get random phrases. Oh, that's a pretty good you rang. I haven't played with it long enough to know if they're going to go in an order, or if you can get the same one twice, or what the randomness is like. This is great. So this is meant to go on your door or a wall or a post or something like that. And it's pretty cool. I wanted to get a look inside of it and see what we can see. It has a mechanical eyelids that open up when you press it, and they have a spring return on them that's pretty strong. So some cam on a motor, I think, is involved in pulling that open. And then it's got a eyeball that feels kind of like a large ping pong ball material. It's painted and it has a LED. It always glows the same color. If you look, it is a bright green. And it blows out a bit on the camera here. I can just for a moment try to bring down that exposure. So basically just a steady glow from an LED there. Sorry about the camera wiggling. And let's get to it. So one thing, by the way, I was looking at, there are a few different props like this that have a tryout button at the store. And the tryout button is kind of cool because it's usually a little button on a tag hanging off the side that says try me with a wire. And it is plugged into the device with a little like Pico blade connector, and it's meant to be unplugged and not used because there's usually some other way that the thing triggers, if it's motion activated or some other button, or if it's on a timer. But they put these little buttons on at the store that are kind of cool, and those look like a neat thing that you could hack with a transistor or a relay to have the thing go off when you want it to, based on some microcontroller based event if you want, or other circuit. But this one has the button right on it. So let's get in here and start poking around and see what's what. So I'm going to get some cutters and screwdrivers and things to get in there. There's a big zip tie holding the device to the card. This, by the way, I looked it up just briefly. Gemmy, G-E-M-M-Y, is the company behind this. They are the ones who came to market with this a number of years ago. In fact, I'll show you a website dedicated to it. And then I believe there are also knockoffs, but this was the original one, according to internet research. And so this is, if you look up eyeball doorbell, this is a fandom, gemmy.fandom.com page. And so this talks about the different versions of them, the phrases that are on them. So it says, this series of animated Halloween decorations made from 2015 to the present. They come in different colors, and they have an eye within them, hidden with the eyelid, push button underneath. And there's some different colors. It tells you what phrases are on them. There are also some other products, such as crystal balls and other things that share the same phrases with some of these. And there's a number of designs. So the one I have is their sort of standard one, I think. But then there are some pretty cool other shapes. It's a little Frankenstein one. I've seen that one at Lowe's before. I didn't get it. I think that one actually has a cool switch, knife switch on it. There's a Ouija board one. So kind of a cool thing that it has this this sort of longevity and has been around for a few years now. And but yeah, I didn't find any teardowns or hacks of them online, so I thought that would be fun to dig into this one. That's in stock. I'm checking my I've got my Discord on the iPad over here, so I can keep up with the conversation. So first thing we'll do is let's take a look at the battery situation. Like a lot of these types of gizmos, there's a little Phillips screw to unscrew to get to the battery. Little battery door comes out, and then those some AAA alkalines, 3 of them. And sometimes it's fun to see what weird brand of cheap alkalines are given to you for free. So these ones, try to focus that in. These are called Ultra Alkaline, and they went with both the K and the C spelling. GFS is the brand. They're not as light as some cheap ones I've experienced before, but you may want to replace those with some higher quality ones, or maybe even some rechargeables, or just use those until they run out. But take them out after Halloween if you're not leaving this thing up, because these will leak. They love to do that. So now we've got 4, let me get a bigger bit on here. We've got 4 Phillips screws, it looks like, to take apart. Where is my larger Phillips bit? I have lost a large Phillips bit. That's okay. We'll grab a flathead instead. That usually works better on these, because these are sort of self-tapping screws that just tap into the plastic. And they've got some bite on them. Of course, you don't want to do this too many times, because they won't, after a while, survive multiple screwings and unscrewings. And, oh, that one doesn't want to come out. Let's try that again. Nice paint job on this. They did like a little metallic or wood grain kind of brush look in a silvery bronze paint. And let's sort of gently tug on that. I actually do like to use a little spudger to pry those up if I have one on hand. Let's see, I may have brought those inside. No, here's these iFixit kits, by the way. I have a couple of these now. My mom got me one last year, and I've had one that they gave me. iFixit gave me many years ago. Kyle did. Thanks, Kyle. Got a lot of good different little spudgery things that are good for prying up plastic without breaking tabs. Okay, so we've got the speaker on the back, and that's held captive with a couple of screws. There's some hot glue on the wiring, which is nice. How nice of them to do that. Probably just keep it out of the way of the mechanism. And there's the battery pack back here. And then we've got the guts on this. So, looks like there's 2 motors. We've got one here that's on a little belt and pulley. And I think that's used with this little cam to move the eye side to side. So, as this goes, it looks like it turns really slowly, but you can see that moving this right here. Let me see if I can get the light in there better. You'll see that as I turn that is very slowly moving that eyeball like that, side to side. This other one is what just yanks open and closed the eyelid. So actually it yanks it open, and what it has is a big sort of semicircular cam and a string, and it pulls on both of these to yank the eyeball open and closed. So as those strings pull, you get eyeball open and close. It pulls both of them at the same time, which is a little hard for me to do with my fingers. And so we'll take a look at how that works. Same sort of thing. There's a little pulley with a belt. If you run across one that's not working, I would say there's a good chance that the belt has gone. So that may be, if you find one at a thrift store for $1 and it doesn't seem to open, that could be worth getting and trying to fix that with a small belt. Let's see, we've got capacitors soldered directly to the motors to prevent all the noise from messing with things. All right, well let's run it a couple times with it open, and then we'll start taking things apart a little further. How about? I'm going to guess there's an epoxy blob hiding whatever microcontroller, if there is one, should be, that's handling the playback of the audio and motors telling them when to go and light up the LED. This, by the way, I think is the LED here, this green and white wire. I think the LED is just in the end of the mechanism that tilts this eyeball side to side. So here we go. Getting a little closer. You can see these motors do their thing. Yeah, so interesting. You can see they actually are moving the motor in both directions. Sometimes these things will work. The mechanism will be such that it just spins in one direction, and that is handled by the gearing. But this is spinning one revolution in each direction and then heading back. The other one for pulling this, maybe I'm going to detach the audio. How about? So one trick in here in these cases is that hot glue usually will come off really easily with a little bit of isopropyl rubbing alcohol. I think I have no Q-tips in here, but I can just use a little tool to drip some on there. So that's usually going to just pop the glue off so you're not picking it off and risking damaging things. So you can see here, see that. Just putting a little hot alcohol on this little spatula spudger has loosened it right off of that. There you go. Look at that. There's the hole. Grab that like a surgeon with my forceps. You can see that just popped it right off. So this, I'm going to take a picture of this so I can get it back together later. A recommended step if you're pulling stuff apart. Okay. So now I can disconnect the speaker, which will make life a little easier for talking to you and not losing my sanity. Okay, so that little connector right there was the speaker. So now we can press this and get just the motor action, and look at that. Okay, so you can see when when we press the button for the eyelids to go, it just pulls it and holds it there, which is impressive because that's probably drawing quite a bit of current to just hold that thing back like that. I don't see it like latching mechanically, so it's just yanking that thing down. And there's a good bit of tension on that because the springs are pretty strong that it's fighting. The springs, by the way, are actually these, it's kind of a coil in the center and straightened legs, kind of like a, right in there, you'll see a little metal coil. So that's the spring that wants to push those back. So let's see what else. So yeah, there's the opener. Let's unplug everything. So I'm gonna go at it with some more rubbing alcohol, which is also a mostly electronics friendly way to, you're not probably going to ruin anything in there or short it out or anything. Just let the rubbing alcohol dry. So there, yeah, it just pops right off. So the orange and gray wired motor goes here on the bottom right. I'm going to see if I have a something that'll make it a little easier to pull that out than fingers. Okay, the yellow, I'm guessing, is the button. Yeah, so I just tried pressing the button with that yellow wire unplugged, and it will no longer work. So this is the batteries up here. And then at the bottom we have our eyeball motor that goes side to side. That was a pretty tight fit wiring wise. Okay, now we got the back door off of there. Let's see, further disassembly to get, I'm kind of curious to look at this PCB here. There's one screw here. Let's see if that's all that's holding it in place. And good to have a little tray for your, or something to hold your screws while you're doing this. I'm gonna grab one of these snazzy CountyCom parts trays. The door in there. And let's see if that wants to come out yet. It does not. Let's see, I don't think there's screws from the front, so what's holding it? It's possible that, I think this is one piece. I was going to say it's possible they screwed it and then added a layer. That looks like a single piece. All right, well, there's a number of these screws that are holding things in mechanically. Let's attack them, why don't we? Maybe a little tricky to get things back together at the end, but let's go for it. Yeah, so these are these little Phillips screws with, I forget what these are called, with the built-in, essentially a washer, that are being used to hold things down. Someone tell me in the chat if you know, I can never remember. Toddbot says, quite a lot of hand assembly for something like this. Yeah, this machine isn't going to build this, so someone's doing a lot of hand assembly on the line to make these things. I know there were a lot of shortages of Halloween stuff this year. If you looked at a big box store like Target, they just didn't have much, and it went away pretty quickly. Okay, so if we pull that, it looks like we'll just have to slide it back into that eyeball mechanism. So now we can see what that's all that does to move the eyeballs side to side. You can hand actuate that now. And you know, one of the interesting things with something like this is that you can graft your own motor controller. Any of the like the motor wing shield or the motor feather wing to drive these DC motors, and you can do, or the Cricket, for example, you can do reversing, forward and reverse on them with those controller boards. Ooh, a lot of weird grime on that side of it. Gross. It's not. Yeah, I guess that it's probably some grease stripped there, but also just some grime. So let's see about this next guy. Get a little more rubbing alcohol because they blobbed on some hot glue there too. Goodbye, hot glue. Yes, you can see here they've also used some of the hot glue as sort of strain relief on the solder joints, which is smart, just even vibration from shipping on some of these tiny solder joints. They want to avoid failure there. So this one is going to probably be the trickiest thing to put back together because I think this motor and its cam that are attached by this little string might need to come out as one unit, so I'm not trying to thread things. So I can't just pull this motor out here because of its attachment to that string. So it may be time to try to pull the whole eyeball out. So let's take out some of these. Y'all are going to help me get this back together at the end, right? Also, are you like me where you go a certain level deep into unscrewing things thinking I can just remember where those screws go or figure it out later, and then you reach a point where you're like, I'm doomed. And I really wish I had laid out the screws in order. Okay, so I think that holds the whole eye mechanism, just those two screws. So I don't need to take the eye mechanism any further apart. And now, let's see, I'll probably, the only issue we'll have is there was no connector for the LED. It's wrapped around this board and soldered in and hot glued. So let's just take a bunch of things out. We'll take the motor assembly and the eyeball, like so. Zoom out just a little bit. So there's that guy. And there's not an easy way to get the LED out. It's pressed in from the front, and then these wires come down here, wrap around, and are soldered. So I kind of need now to really figure out how this board is held in, because it is held in place. These two screws, they're kind of hard to get at, and I think they're holding the button assembly in place. This is acting like, oh, I see, they hid a screw on me under this hot glue. That's all it was. So let's maybe it's time to pull the eyeball out is an unsettling phrase, you're right. Maybe. Pop that off. A little blob of hot glue, and now we can get the board off. Okay. It was not as, I outsmarted myself. It was not that tricky. The old screw under the hot glue trick. Works every time. Okay, that was one of those. I'm kind of keeping the screws in little clusters, so I hopefully remember who's who. Doomed. Okay, so I can leave the button in. in place there. There's no reason to take that out, but we've just got like a in there. And now we can see what's what on here. So let's get our fullest available zoom. We are at our fullest available zoom. Okay. And what do we see? We got 3, 4, 5 unsoldered pads. These seem to probably just be on the ground plane. Yeah, there's 4 unsoldered pads for ground. We have a microcontroller that's sitting under that blob there, so no real chance of knowing what it is or what it does. And then a bunch of passives. I'm guessing this is power boosting here for whatever it needs. Nothing is marked as far as any functions or anything other than just telling you the components on here, resistor values and so on. So yeah, your best bet, I think, with a lot of these, if you want to try to do things to them, is really to attack that button right there. So essentially put your own transistor or relay in line with what this button was, or cut this button out of the system essentially, and then you can turn it on and off at will. You're not going to be able to, I know a lot of people ask, oh, I'd like to put my own phrases on here. If you're going to try something like that, you're, again, essentially going to ignore the entire microcontroller board at that point and instead use something like the Cricket or some of our, maybe like the prop Feather, the prop maker Feather, which has, Featherwing, which has, you could do CircuitPython MP3 playback, and it has a little amplifier built in, so you could run to this existing speaker that is in here. So you can transplant essentially the brain and use the mechanism and the motors yourself. Drive the 2 motors. You could drive the LED with some PWM so that it has a little bit more of a trick than just turning on, which I think is what this one does. I think this just turns on. Let's see. Should we? I guess it's always fun to try it out while it's unplugged or pulled out of the system. So if I can pull up my photo of what plugs in where. Let's see the mess of my phone. Hey, Lars. There we go. We can follow. I've got a little picture here. Follow that to see what's what. And so that's the orientation of things. LED's already in. This is the battery power up top. Let's just do that, and the I can just bridge this for the momentary switch rather than connect that, because it's pretty short and inconvenient. Or let's see, can we jam a couple of? Let's see if we can jam a couple of wires in line with that. If I have 2 appropriate, not you. Sorry, just sorting through wires on my bench here. And these are all, none of these are going to work. All right, hold on. Okay, so I'll just bridge this. So what we should see here is just the LED go. That is the, oh, wrong one. There we go. There we go. So there's the LED doing its thing. It's a bright one. Pull the eye out of there. So that does its whole timer thing. It would go motor, audio, all that at once. So let's take a look at this little mechanism a little closer. So trying to be careful not to ruin it. I think that just rests there and there inside of the mold of the plastic. So here's our motor. We can simulate eyeball opening by pulling on those two strings, and then that is our eyeball motion there. That I won't run that while it's out because it'll probably do bad things. Let's take a look at this one though. If we plug, who are you? You were the far one. They even did a bit of color coding, not perfect, but useful. So how was this guy? I think like that. Yeah, it's in there like that. So this is what is cammed onto there. So if we, let's see, is this thing ferrous or conductive? Yeah. Yeah, so it does these little kind of half steps and then continues them on for most of them. The first one, it goes just a half step and then back and then other way and back, other way. And if we hold up the eye there, you can see that's how that turns. Pretty cool. And audio-wise, this is our speaker port up here. Give that another go. It's quite loud. I'm impressed by how loud it is. And you can see here it's bolted down really seriously, so you get some resonant effect too of the plastic backing there. It's probably not anywhere near as loud if you pull that out, but really cool. So let's see if we can get it back together. I'm not going to try to do a microcontroller hack on this right now. I might try to do that before trick-or-treaters come. Anyone doing any, in the chat, anyone doing any Halloween prop building, decoration hacking, that kind of stuff? Would love to hear about it. All right, let's see. Let's get this board back in the right way and then proceed with the other parts. Hamslab says, right now I'm working on using EL wire to make a lightning effect. If you pair white and blue or white and purple and flash them really fast, white 20 milliseconds, the other one 20 milliseconds, it looks really like lightning. Oh, that's cool. SparkFun has a shield to control 8 EL wires, and I got a Metro ESP32S2 from Adafruit and wires, EL wires where I could find them. I'm putting it together after this. Oh, that's very cool. We'd love to see that. Please show those off in the show and tell. All right, so I think this will go in like so. And what's this yellow one? That's the switch. Yeah, we'll leave that like that. All right, I don't know how interested you're seeing in the put back together, but it's at least put some pressure on me. Can I get this thing back together? This is why I got into this business in the first place, is because I spent a lot of time as a kid basically doing this. Like I'm sure many of you did. Taking things apart and then being amazed if they went back together. Those are the wrong screws. I did it already. These are the ones I need. Those could use a smaller screwdriver. Tip. Interesting too, they've got a guide, I think, for polarity of the LED on here that's this silk screen. I think that's showing anode and cathode in a way I haven't seen it, that sort of circle with the lines in it. Is that what I'm seeing there? Usually you see the circle with one flat side. It's also got the plus and minus on there. Okay, our board is back. Our switch we can plug in. Our eye motor goes in like this. I think the trickiest part, if I had to guess, for me to get this thing in correctly is the cam for the eyeball left and right, getting that situated properly. Does this look right? Was this at an angle like that? Is that at all where that was? Yeah, it is at a little bit of an angle. Okay. So that's held down with one of these here. You know what? I should probably put the eye in first and get a sense that it's going to continue to move as intended. Does that look right? Let's see, this string I think goes around here. You can see actually they may have intended the string to go through, the top one to go through there at one point and change their mind. It looks like it goes through this little valley here. Does that seem right? Does that seem plausible? Let's plug it in. So that wire plugs in here. Okay, that's eyeball in place. Seems like things will move. All right, you know what I'll do? I will screw in the eyeball mount and then test that. Michael Lackock says, I remember always taking things apart when I was a kid. I don't think I ever really put them back together then, though. That's as far as I feel like going. I've seen how it works. Give you a better view there. Okay, so let's try to get the motor seated. It looks clear. I'm going to move the LED wire over here a little, and let's give it power and test that out. So power, we really think you were up top? Yes, we do. button is plugged in. Let's try it. Good, okay. So it opens and it should close. All right, that's a good sign. We'll go ahead and screw in place that motor. Oh good, Ham's Lab said they're going to do show and tell next week, and thank you for Kattni for providing info on how to do that. If you ever want to show stuff on our show and tell, just head on over to the Discord live broadcast chat right before the show, and we will drop a link in there, and then you can go into our StreamYard lobby where we stage it. Okay, so time for, this is the one that I said I'm a little nervous about because it's a gamble if I'm actually going to get this in the right starting place. Let's see where the motor was to begin with. Okay, you know what? It kind of locks when it gets where it wants to go, and I haven't forced it by hand, so I will put it in that little groove. That's looking plausible to me. Let's plug that motor in and we'll test it out. Let's see. I don't have a good way to cut the power if it starts shearing things, so let's just hope for the best. I will be ready to pop a battery out. How about? That's probably the easiest way to interrupt things. Yeah, it's doing it. Okay. All right, good. We have it back together, all the hard stuff. So let's just finish that up. You know, you could also probably do some fun stuff just by interrupting or putting your own trigger for it and your own audio into the speaker there. If you wanted to have some other phrases, or if you wanted to have a live microphone so that you can watch people. I have friends who do this where they watch the trick-or-treaters through a webcam and then say things to them from a ghoul on the porch, that kind of thing. Have a little interaction. That can be fun. And we're just about there. We just have audio plug and to close it up. Usually a good idea to gently close things up. See how wires want to get pinched, especially because I've now gotten rid of all the hot glue that was helping with wire management. So you got to be a little careful you don't go pinching wires or driving screws through them. But once that's plausibly in place, I'll turn it over and just test it again. Good fun, this one. I'll spare you maybe the last wire wrangling that I'm going to have to do to get that actually sealed up. Because actually I think I want to mess with it more, so I'm going to leave that open. But thanks for hanging out for a teardown. I think a lot of these Halloween props are pretty interesting lessons in really effective, durable design for mechatronics. So are always worth just learning from. But in this case, we can also, I think, do some modification to it. And let me know if you're interested, and I'll consider doing an extra follow-up on this one and plugging at least the motors and audio into one of our driver boards so that we can make it do what we want to do when we want it to do it. I think that's going to do it for today. So thanks for coming by. Thank you for the people who are over in the YouTube. I see you now. Thank you for hanging out. Oh, I like this. One of the suggestions is using a egg carton for holding a bunch of screws. That's an excellent point. In fact, I have a tiny ice cube tray over here that I've often used for that, but it's full of parts right now. Also, someone pointed this out to me. I think Mr. Certainly pointed out, and I've been following this notion. The top of that iFixit screwdriver case is a parts tray. So I've got that now. Actually, now I don't remember what those screws are from. Great. That's going to do it. So happy Halloween, everyone, and I will see you next week for a new product pick of the week on Tuesday and John Park's Workshop on Thursday. That's going to do it. Bye-bye, everyone.